So to calibrate the board, you need to apply power to the left-hand side of the board, and you need to take your CT, which is on your fancy board thingy with light bulbs, which is plugged into the wall via a kilowatt meter, and you need to put that in either one of your inputs for power monitoring. We know we have power, the light is on. That's very nice. When you do so, you take your multimeter, you want it on hertz, which is your frequency counter. You turn on your light, and you take your leads of the multimeter, I think that's what that's called, and you take them to analog ground and measure test point. And what you're getting now is a number that is proportional to the power being drawn by the light bulb. And you can only move, one of the parts allows us to change that number. And what we want to do is we want to change that number to something that creates us an easy multiplication factor. So we're going to do this one to, we're drawing 102 watts, or volts rather, which we know from the kilowatt meter. And we're going to calibrate this board by turning the screw on the analog potentiometer, and we're going to calibrate it to 255. And on a 20 amp circuit, or on a 20 amp CT, that's going to give us the equivalent of 2.5 hertz per watt. And that's important to remember because you can take this board, and because you have that known factor, you can take it to different amp CTs that are installed in the buildings, and you'll be able to calculate the power for the building. We're going to take this one to 255. And you'll never quite get it exactly on 255 or on any exact number. You'll get it probably fluctuating within 0 to 0.03. And that's good enough for our intensive uses. Oh, 5 is no good though. That'll work for me. And so you've then calibrated the left side of the board, and you can go on, or you can go on to installing it in your dorm, or you can go on to programming, completing the circuit, whatever step you decide to do next.